Welcome to this video on lesson 4.7, which is use isosceles and equilateral triangles. So in class, what we had to do was we had to create, we were developing the properties of an isosceles and equilateral triangle. So the first thing I had you do was you needed a compass and a straight edge. Now you can always use any various pens or pencils that you want. I'm going to use these dark pens so that you can see for the video. So the first thing that I had you do was draw an isosceles triangle. Now, if you recalled from my first lesson on construction, you needed to always draw a line segment as your first part when you're drawing a construction. It doesn't have to be long, it doesn't have to be short, it can be any distance you want. The key thing is that it must just be a line. So the first thing to draw an isosceles triangle is, an isosceles triangle has two line segments that are congruent. So all you have to do is choose a point that is off your line. From there, you just want to open your compass so that it crosses your line on two spots. Put the point of your compass on the point you chose and swing your compass so that it crosses at 2 points. Where it crosses those 2 points, that's the 2 points for your isosceles triangle. So you put the point of your pen here and connect it to where it crosses your line. There you have an isosceles triangle where these two sides are congruent. That's all it takes, guys. Next, what you had to do was use your compass to bisect the vertex angle. Now, what you could have also done, which you'd have the power of the internet, since you're watching this video, you are going to take the vertex angle, which is the angle that is created from the two congruent sides. So the two sides that are congruent, the angle that is made by those two sides is called the vertex angle. So from that, what we need to do is bisect that angle. To do that, we put the point of our compass on the angle, and we're going to swing an arc that crosses both sides of my triangle, or of my angle. I'm going to decrease it just a little bit. So I'm going to swing my arc that crosses both sides. Now I've got a measurable distance that I can measure with my compass. So then you open your compass or close it so that it matches with the width of the angle. So doing that, put the point of my compass here, open my pencil to there. And what I'm going to do is I'm going to swing an arc out here inside the triangle. So I'm going to swing an arc the width of the angle. Now don't change the width of your compass. Go to the other point that you have intersection on the side and swing another arc. Again, put the point of your compass on the other intersection point that's on your triangle and swing an arc going the opposite direction. You'll notice the two arcs cross. That point of intersection of the two arcs is where you're going to place your pen to draw your angle bisector. So the line that you connect between the intersecting arcs and the vertex angle bisects the vertex angle. So those two angles here are actually the same value. So altogether, next part we had to do was prove that the base angles, which are the two angles down here, are congruent. So these two angles are called base angles. So we don't know in our diagram, even though I've drawn them as congruent, we don't know that they are congruent yet. So that's what we have to prove. So the first thing is anytime you're doing a proof, you always write down your given. So the first thing I know, if I want to label this to make it easier, do so. So I have A, B, C, D. So the first thing I know is AB is congruent to CB, so that's what I write. That's given. Or you can also say, since we constructed it, that's the definition of an isosceles triangle. So here's our statements. Here's our reasons. So next, we have our two angles that were created from our bisector, our angle bisector. So that means angle ABD is congruent to angle CBD. And we know that because of an angle bisector BD. BD, we constructed it as an angle bisector. And the last thing we know is BD is congruent to itself by the reflexive property. So if we look at what we have a side, we have an angle, and we have a side. And nicely in that order, side, angle, side, side, angle, side. So then we can say these two separate triangles are congruent. So triangle ABD is congruent to triangle CBD by side, angle, side. Now again, what we wanted to prove were these base angles congruent. So that means we have angle A congruent to angle C. And the reason they're congruent is because the two triangles are congruent. Remember, CPCTC. Corresponding parts of congruent triangles are congruent. So because I have the two triangles congruent, I know the two base angles are congruent. So that was what you should have done on your exploration. The second part of the exploration was you need to create an equilateral triangle. So the equilateral triangle you needed to create was from a square. So I gave you a square piece, or roughly square piece of patty paper. You needed to create an equilateral triangle from that piece of patty paper. Your first step was to fold your square so that you had a 30, 60, 90 triangle. This is kind of an experiment, but you need to remember in a 30, 60, 90 triangle, we might not have talked about this yet, but regardless, you also have the power of the internet and Google. In a 30, 60, 90 triangle, the side opposite the 30 degrees is half the hypotenuse. So when you fold your triangle, you just have to, the first two folds you make are going to be, you got to remember the hypotenuse is twice as long as one of the sides. So once you do that with the one 30, 60, 90, you can do it again with the other one, and what that does is that gives you these two lines, which end up being the same length as your side here. So if your side length of your original square is 1, then the side lengths of your equilateral triangle will also be 1. The third question at the very end of the exploration talks about like, would it be possible to make the triangle side length bigger? That's a question I'm going to leave up to you, since it was part of your exploration. But if you want to, I will put in a link to another video that describes that. So let's look at what we did in class. What you should have noticed about the equilateral triangle is not only are all the sides equal, but the angles will also be equal. And we'll talk about that right now. Okay, so some information that you need to know. From the isosceles triangle investigation that we did, the exploration we did on the isosceles triangle, there's a few things that we need to know just to classify and clarify parts of an isosceles triangle. Apologize for my hasty drawing. Just assume that this is congruent. So, when I have an isosceles triangle, the two sides that are congruent we call legs. They're each a leg. Okay? And this angle here, as I said before, is the vertex angle. There's only one vertex angle. However, the base angles, which we've already proven are congruent, are these two angles that are not the vertex angles. And the reason they're called the base angles is because the third side we call the base. So again, the leg are the two congruent sides. The base is the non-congruent side. And the base angles are the angles opposite the legs, or you can say adjacent to the base. And so from that, we get our theorem that we used in the exploration, which is the base angles theorem. The theorem that we proved here is called the base angles theorem. Because we proved that the base angles are going to be congruent. So what this is basically saying is when I have an isosceles triangle, and I know it's an isosceles triangle, let's say triangle ABC, if AB is congruent to BC, then angle A will be congruent to angle C. So this is what's going to be true. And you'll notice A is opposite BC, and C is opposite AB, and vice versa. They're opposites of each other. Now this theorem has a converse. If you remember what the converse is, all I do is switch the if and then statements. So what this would be is if angle A is congruent to angle C, then I know it's going to be these two sides congruent. So that makes it an isosceles triangle. So the reason why I put both arrows on each end is because it goes both ways. Okay. Next, we're going to talk about equilateral triangles, and then we'll do some examples, and then we will show you your two problems to do. So, some corollaries. And a corollary is just taking a theorem we've already proved and changing it slightly or adding to it. So the corollary to the base angles theorem says if a triangle is equilateral, that means all the sides are the same, then it is equiangular. So I'll draw that real quick. And you guys will remember from class that if you use the ruler to measure, it doesn't turn out the way you want it. And that's exactly what just happened here. So if I have triangle ABC, and I know it's equilateral, then I know that the angles will also be the same. And this also has a converse, which means if I switch the two, the if and the then it's still going to be true. So this is the corollary to the converse of the base angles theorem, which was if I switch the angles, so if I switch it, if the angles are congruent, then the two sides are congruent. So this is the corollary to the converse. So the corollary to the converse of the base angles theorem says if a triangle is equiangular, then it is equilateral. So the two here that I have are converses of each other, and this is an addition to the base angles theorem, and this is an addition to the converse of the base angles theorem. So with the two together, I can combine them and say a triangle is equilateral if and only if you remember IFF stands for if and only if, it is equiangular. Okay, so let's do some example problems. So look at the first one here. It says complete the statements. If HG is congruent to HK, then, so the first thing off is I notice HG and HK are congruent. So let's mark that in my diagram. HG is congruent to HK, which means in this triangle I have an isosceles triangle. And what do we know about the base angles of an isosceles triangle? Well, we know that they are congruent. So that I can say this angle is congruent to this angle. So what I write is angle G is congruent to angle HKG. Now the reason I'm using three letters here is because I have three angles at letter K. I have HKG, HKJ, and then I have the whole of angle K from one end to the other. So I have to make sure I designate what I'm talking about. Otherwise, there's too much confusion. The second statement says if angle KHJ is congruent to angle KJH, so KHJ, so this angle is congruent to KJH, this angle, then, well, I know since if the base angles are congruent, then I know my opposite sides will also be congruent. So that means HK will be congruent to KJ. Or if you want, you could do HK congruent to JK. Ha ha ha, so funny. So that's our first problem. Next, find the values of x and y in the diagram. So, in this example, we have to use all that we've been given to find the unknown values of x and y. So to do that, I look at the fact that angle K is the same as angle NLK, this angle, and the same as KNL, this angle right here. So that means this triangle, KLN, is an equilateral triangle. So that means this side is congruent to that one and that one. So that means because it's all three sides are the same, that means y equals 4. So y is 4. Next, I also notice with this triangle that the base angles are the same. That means the opposite sides will be the same. And since we already know that this side is 4, I know that x plus 1 should also equal 4. So that means 4 equals x plus 1. Subtract 1 from both sides, we get 3 equal to x. So y is 4 and x is 3. These are two really simple problems that you should be able to complete on your own. The problems I've given you in the multiple choice and free response are a little bit more complicated, but they shouldn't be too difficult for you. So here's your multiple choice question. Pause the video now. And here's your free response question. Enjoy.